And now for the motivation behind this course. As the energy landscape shifts towards decarbonization, electric utilities play a crucial role in enabling a cleaner, more efficient future. Buildings, particularly mid to large facilities, are among the largest energy consumers, and their HVAC and central utility plant systems present significant opportunities for carbon reduction. This webinar is designed to help facility managers, engineers, and sustainability professionals evaluate their systems through the lens of decarbonization, efficiency, and electrification. By improving HVAC performance, integrating emerging technologies, and leveraging utility programs, organizations can cost-effectively reduce emissions and enhance resilience. Electric utilities are committed to supporting customers in this transition by offering expertise, incentives, and solutions that make decarbonization not just an environmental necessity, but also an economic opportunity. Join us to explore how strategic system evaluations can drive meaningful progress towards sustainability goals. And now it's my pleasure to introduce today's presenters. Joining us are Andrea Hildan, Jacob Alameda, Raleigh Moyer, and Ryan Hammond. Andrea is joining us from Glumac. Andrea entered the industry as a mechanical designer, and through her passion for sustainable and energy efficiency designs, moved into her current role as energy consultant. Andrea was drawn to Glumac's motto, "Engineers for a Sustainable Future," and believes it is her responsibility to employ this on a day-to-day basis within her projects. Andrea's recent projects have been concentrated in the higher education and government sector, bringing sustainable design to student residences, academic buildings, and a variety of city, county, and state buildings. She has eagerly led a variety of existing building electrification studies and exhibits a true passion for decarbonizing the built environment here in Sacramento. Andrea has brought her passion to projects such as the California Department of General Services statewide decarbonization plan, Resources building renovation, and Gregory Bateson renovation. She has also worked with SMUD on their energy efficiency and electrification plan. Jacob is also joining us from Glumac and is an associate mechanical engineer specializing in HVAC and building systems. He is knowledgeable about electrified mechanical systems, energy efficiency, and healthy building design practices. Jacob's recent work experience involves projects in the higher education, science and technology, and government market sectors. From campus infrastructure projects to smaller building renovations, Jacob has experience guiding project teams and owners on mechanical system designs to best fit project requirements. Raleigh is joining us from Sacramento County. He graduated with his Bachelor's of Science in Mechanical Engineering from UC Davis. He worked in consulting MEP design for 8 years, first for an integrated architecture company, LPA, in Irvine, California. And later he relocated to Sacramento, his hometown, and worked for Peters ENG as project manager, client manager, and mechanical engineer of record. He started working for Sacramento County late 2023 as an associate mechanical engineer, where he designs smaller project construction projects and manages consultant teams on larger efforts for county facilities. With over 10,000 employees, he just did a check on the directory, and he thinks that he is the only county-hired licensed mechanical engineer on staff. And rounding us out is Ryan Hammond, who is SMUD's senior mechanical engineer working on the Integrated Design Solutions program. In that role, he manages new construction and extensive renovations. He supports owners and design teams not only with incentives, but also technical support with the goal of optimizing designs further. Prior to SMUD, Ryan worked for 5 years as a consulting mechanical engineer for commercial buildings. He earned his BS in Biological Systems Engineering and a Master's in Mechanical Engineering from UC Davis and is a licensed mechanical engineer. In his pastime, he raises bees, I can testify, loves camping in his wood-fired stove tent, rides his fat bike in the snow, and actively immerses himself in cold water a la Wim Hof. And with that, I'm going to hand the reins over to our team of instructors to take us through the presentation. Thank you, everyone, for joining us. Andrea and Jacob, please take us away.
Yeah, thanks so much, Joey, and thanks everybody for attending today. Before we dive into today's content, I just wanted to spend some time really emphasizing that Today's presentation is specifically going to be focused on existing building electrification rather than new construction. And then specifically, we're going to be focusing on larger scale commercial buildings equipped with central plants. That's not to say there's not electrification technology out there for residential applications or smaller commercial projects, but just not something we're going to be covering today. So for today's content, we're going to be covering 5 core areas. The first section being defining what decarbonization is and how carbon emissions are impacting our communities. We're then going to transition into specifically how current legislation is pushing building owners to take action. Then we're going to dive into specifically
Turn your video off and I'll get off the phone and fall apart because you got done
common electrification strategies we're seeing in the industry.
Yeah, just hang on there.
And specifically how this technology can and should be implemented as seen in the case study we're going to be sharing today with Sacramento County. And then we'll wrap up today with some of our core lessons learned as each of us has worked on an array of electrification projects. As far as question and answers, we are allocating some time at the end of today's presentation to cover any audience questions. So please hold those questions until the end. You can definitely drop them in the chat as we cover different content. And if you want to refer to a certain slide that we covered, definitely do so. But with that, we're going to go ahead and dive into the first section. What is decarbonization? I'm really passionate about this slide just because I feel some of these terms are often used a little interchangeably when it comes to sustainability, decarbonization, and electrification, but I think this slide really does a great job of describing the relationship between these. So when we're talking about sustainability in the built environment, specifically, we're measuring that sustainability in terms of carbon. So specifically, we're looking at metric tons of carbon dioxide being emitted annually from the buildings. And we essentially strive to decarbonize these buildings by lowering greenhouse gas emissions and helping to mitigate their climate change contributions. We can then achieve decarbonization through electrification of the building systems by transitioning these equipment away from gas-powered sources. On the right half of the screen, I wanted to spend some time helping to clarify the 3 different types of greenhouse gas emissions that we're often looking at within the built environment. So first, I just wanted to address Scope 3, which is often referred to as indirect or unowned emissions. For this presentation today, we won't be diving into Scope 3 emissions in too much detail, but generally we see these pop up in a lot of things like sustainability and climate action plans, where entities outline goals for reducing things like waste and water use within the building. The 2 that we will be focused on today are Scope 1 and Scope 2 emissions. So Scope 1 is what is referred to as direct or owned emissions. This is specifically what ownership has on site that's being combusted or burned. So specifically, that might be things like your natural gas boiler or a natural gas water heater. And then the last one on the slide here is your Scope 2 emissions. So a lot of times we like to think of this as indirect or owned by a utility. So our partners here at SMUD specifically are looking at their Scope 2 emissions when it comes to electricity production here in the county. With that, I'll go ahead and transition into the next slide here. Now that we've addressed what is contributing to carbon emissions, I wanted to acknowledge a handful of environmental impacts that we're seeing here in our local community. Whether we want to address that these are contributing to what's known as the climate change phenomena, I think what's really important here is playing up the resiliency card, and specifically any of these systems that we're installing in buildings should help to keep our buildings online and active when we're faced with any kind of inclement weather that can lead to system malfunction or downtime. And the last point I really wanted to help contextualize on this slide here is helping all of us kind of visualize the impact carbon emissions have from within the built environment when we're evaluating at the state level or the county scale how emissions are contributing across the entire economic sector. So with these 2 pie charts, you can see that on the state graphic here on the left that when we combine our commercial and residential carbon emissions, it makes up the 3rd largest contributor to the overall state emissions, whereas on the county side here, you can see that commercial and residential makes up the 2nd largest piece of the pie when it comes to carbon emissions. So just understanding the impact the built environment has on our entire economy, I think, helps to legitimize the urgency and funds that are being allocated to tackle decarbonization here, specifically in our local community. So staying in tune with the local community, I wanted to pass this over to Ryan to talk about how SMUD's working on their clean energy vision for us.
Thank you so much. Yeah, this is super exciting. So with this focus of addressing scope 2 in our utility service territory, we have a SMUD 2030 clean energy vision that we're going for. So by 2030, which will be here when I blink, 2030 will be here. It's right around the corner. Our goal is to have 100% zero carbon generation. The secret, though, and the key to this is while providing affordable, reliable, and equitable power for all. So we want to do this within reason. And want to share with you that really up to 90% of this goal will be achieved with proven technologies that we have today. So we're just rallying on those, and we have it. The last 10%, you could imagine, is pretty tough to achieve. And what we're looking to do with that is address it with new technology, such as hydrogen utilization, carbon sequestration, or capture, and long duration storage, so like 24-hour storage of clean fuels. Any other approach is using business models like virtual power plants or strategic load shedding on a really wide grid holistic approach. We also have our SMUD community impact plan, and this is in that same vein. It really ensures that under-resourced customers are part of this journey. What's interesting is this is all online, so it's completely transparent, the work that we're doing, and it even offers like prior reports and goals to see how this evolution is happening. You can imagine there's a lot going on. And the wonderful thing is this provides a pathway for other utilities to follow. It's always hard being at that kind of bleeding edge, and this is a recipe, if you will, for clean energy. So in addition to procuring clean electricity, we're also supporting decarbonization on the grid by addressing buildings and vehicles. So buildings and vehicles are, in round numbers, 60 to 70% of the emissions on our grid. To illustrate the comparison on that, SMUD is about 15% emissions on our grid. So we're really trying to tackle the huge chunk of it. We offer technical support and incentives to support customers as they move forward with electrifying. We offer electrification assessments. I'll touch base more on that later. We also offer green pricing options. So in this interim of 2025 to 2030, we're offering customers a solution to be 100% carbon free. And we also have active load flex, which is basically auto demand response. Thank you very much.
Great, thanks, Ryan. Now that we've kind of set the stage on what decarbonization is, we wanted to spend some time acknowledging current legislation and policy that's out across all different levels, whether we're talking federal, state, or even locally. So first, going to start at the federal level. I think the big takeaway I wanted to leave everyone with today is that there's no current policies on a national scale to mandate electrification or decarbonization projects. What that means is authority is left to the states then to adopt and maintain their own energy codes or electrification and decarbonization policy. That's not to say that those of us in the industry haven't paid attention to national or federal policies or incentive programs like the Inflation Reduction Act, or as a group of mechanical engineers, we're definitely interested in what's going on with the EPA with refrigerant phase out and change out requirements. Did want to acknowledge, though, that within the federal level, this is definitely a dynamic landscape, and any of these programs or work agencies are currently doing are subject to fluctuation. So the best place to stay informed is on any of these individual websites to stay up to date with the latest information. But since I did say a lot of the authority is left to the state, I wanted to spend the bulk of our time discussing what's going on in California with our state mandates. Did want to note, by no means is this short timeline here an exhaustive list of every decarbonization-oriented executive order or policy issued by the state of California. The ones that I simply wanted to focus on today were the various executive orders, assembly bills, and Senate bills that have been proposed and codified to have greenhouse gas emissions reduction targets for the entire state. So yes, that's both our public and private entities. It's being capped most recently by the 2022 Assembly bill, which reduced greenhouse gas, has a goal of reducing greenhouse gas emissions to 80% below 1990 levels by 2050, and an ultimate target goal of achieving carbon neutrality by 2045 in California. A few other Senate bills that I wanted to pull out because they're of interesting note are Senate Bill 100, which is the California Renewables Portfolio Standards Program. It's something that's, again, near and dear to our partners at SMUD here, which is looking at supplying 100% of the state's electricity from clean energy sources by 2045. As Ryan already shared, they're a little bit more aggressive with this target, hoping to achieve this by 2030. And then another one that I wanted to address was Senate Bill 1020, which is an even more aggressive goal or target specifically for state agencies to achieve carbon neutrality by 2035, a whole decade earlier than the rest of the state. So again, I think just really promising for the state agencies themselves to be a good role model for the rest of the state to follow suit. Another thing that I wanted to point out with this slide here is specifically you don't see any natural gas bans explicitly written within current mandates, which leads to my next topic, which I think is pretty interesting to note. What is the California Air Resources Board doing to oversee statewide emissions? So again, no outright natural gas bans, but what has been interesting when it comes to air quality management districts within the state, there have been AQMDs like the South Coast and Bay Area districts that have been successful in introducing language that sets really stringent emissions requirements for things like natural gas boilers, furnaces, water heaters, where in actuality there's no technology currently on market that can meet these really stringent requirements, which drives a lot of design teams and ownership groups to switch to electrified options in order to be compliant with the local rulings. What'll be really interesting in the next year is statewide, CARB will be issuing a 2026 final ruling with goals of requiring zero emissions for equipment that's doing space heating and domestic water heating within our buildings. A lot of us in the industry do think that the Bay Area and South Coast AQMD could be precedent setting or help inform future language for this 2026 final ruling. So definitely something to keep an eye out for over the next year. So I know I've thrown a lot of legislation at everyone this morning, so with that I wanted to turn it over to Raleigh with Sacramento County and let him walk us through how the county has interpreted all of these policies.
Awesome. Thanks, Andrea. So yeah, I'm the county's licensed mechanical engineer. I'm a project manager. I bid out HVAC-based projects. We do a lot of scope and estimates and pre-designs, which is kind of going to be what we're talking about today. But I wanted to take a moment to talk about Sacramento's actions in this area. So generally, California, many local governments are developing their own climate action plans. They kind of serve as strategic planning frameworks that include measures of public outreach, feedback. They do public source committees with the goals of these climate action plans to basically create clear emission statements, back that up with regional data, which Sacramento County has done, and then specifically the big kicker is including tailored measures and specific actions to be taken. So for Sacramento County, we've been experiencing a ton of, climate change effects. We've been experiencing extreme heat, strong heat island effects, prolonged drought, wildfire seasons, and it's already impacting a lot of the residents in Sacramento County. So we have, in response, back in December 2020, Sacramento County's Board of Supervisors, basically the elected body by the people who have put together and then issued out this Board of Supervisors in emergency climate action response to this. It's basically a statement that we're going to be taking climate seriously. That was 4 years ago or so. And so the creation of that implemented a climate action task force, a small body of team that really guided our climate action plan. And that this document that now finally, as of November of just this last year, we now have an approved climate action plan for the county. It's a huge win for us. It's really lines up a lot with the state mandates that Andrew was talking about. And for the purposes of what we're talking about today, there's two kind of key metrics in there. there's 2030 and 2045 goals. So for 2030, our goal within Sacramento County, within our climate action plan, is to reduce our greenhouse gas emissions by 39% below 2021 levels. And then the push goal past that would be 2045. We've got reducing greenhouse gas emissions by 83%. So there's a lot more inside the climate action plan, but that's kind of the big takeaway here. If you want, Andrea, we go to the next slide. So you might be thinking, okay, wow, yeah, 2045, that's kind of a long ways off. But I know plenty of you in the public sector or work for government agencies think, okay, we probably should have started on this yesterday. There's a ton of reasons why things that are happening today for us act as pressure points for us to act right now. The biggest one, and I know some of our field maintenance team are actually on this call listening in, is the age of our county facilities and equipment. So the county has hundreds of facilities, many of which are decades old. What you see here in this photo on the left side is our agricultural center. It's an old boiler that's sitting there. It's been maintained really well and has well exceeded its years of service. And so what I'm doing right now, or have to do, is create a scope and action plan to get this boiler replaced. And the things I'm going to look at to kind of weigh into that decision is our climate action plan, because essentially if I were to replace this boiler like in kind for a gas boiler, that thing would last ideally past 2045. So the decision we make today is a 2045 goal. So that the climate action plan directly relates into those decisions. Another kind of reason we might be taking action now is and this is generally the speed at which government operates. Probably not surprising. The county has tons of ingrained processes they generally act as checks and balances for our work to kind of value the tax dollars that we collect from our taxpayers, value them well. But the downside of that is there's just a lot of infrastructure and things that people like me need to do. It's like writing board letters to our board of supervisors. We have to present reports to the county executives, basically justifying it's like a mini dissertation on like why we think this project's important, why it costs so much, why it's so complicated to do. And then, even beyond that, there's like minimum advertisement times that are baked into our public contract code that just, we have to advertise this and give minimum times for people to go ahead and weigh in and ask questions. And then construction timelines is beyond that. So, we couldn't move quick enough for all these things. And this on top of really, this has been weighing on us quite a bit. Most recently, we have just a ton of priorities within the county, is just limited funding to put onto what is our climate action plan. We've got the sustainability funds measured within our budget, but frankly, it's not enough, and we're trying to do our best to kind of advocate for that. And then even layered on top of that is like the staffing challenges of actually getting the work designed. Often my department is relying on consultants like Glumac to do the designs, because I think we already mentioned, like, I'm the only mechanical engineer out of like 14,000 employees, and I couldn't design all these projects myself. So we're relying on our teammates to come in and run these projects. But even with that, there's all the project management responsibilities. So we could not take enough action right now to move quick enough with all of these measures that we're seeing to implement electrification in the county. So for here, I'll kick it over to Andrew, who's going to talk about what we can electrify.
Yeah, thanks, Rolly. I think that's going to set the stage really nicely when we get to our actual case study. But before doing so, we're going to stay a little bit more general first and just talk about our options for implementation. So when it comes to what's inside our buildings, what can we electrify? Typically, I like to think of this as our 5 spheres. So it can be our HVAC that's providing space heating and cooling for occupants. It can be the domestic hot water heating that our occupants are using. It can be our cooking appliances. It can be in the laundry room through currently installed dryers, and in certain instances, sometimes even pool heating. Today, we're specifically just going to focus on HVAC and space heating and domestic water heating on central plant side. So with that, I'll kick it over to Jacob, who's going to talk about space heating technologies.
Yeah, hey everyone. So like Andrea said, figuring out a way to electrify our building's heating source is definitely a big part of decarbonizing our existing buildings. So what you can see on the screen here are some hydronic heating technologies that are commonly used to heat large commercial buildings and campuses. You might notice that there are some technologies missing here, like a packaged heat pump unit or a split heat pump or a VRF system, which can all be great options for many buildings. But for this presentation, we're going to focus mostly on electrified hydronic heating systems that are tailored towards large commercial buildings or campuses. So looking at the screen and moving left to right, each one of these equipment types goes up in efficiency as you move to the right. So the first equipment type on the left is an electric boiler, and that's kind of exactly what it seems like. It's an electric resistance piece of equipment with a COP of 1, which just means that it's a piece of equipment where you put 1 unit of power into it and you get 1 unit of useful heat energy out of it. The benefits of that equipment type is that they have small footprints. They don't need to be outdoors, and they can give you really similar heating water temperatures that you would expect from a traditional gas boiler. The downside is that it is a third as efficient as a heat pump, and using it as the main source of your heating for your building can lead to large electricity demand charges and operational costs down the road. Also, prescriptively, the California Energy Code actually restricts the usage of electric boilers to being 25% of the building's total heating capacity, and really only allows it where it's used to supplement a heat pump system. Electric boilers are a good way to supplement heat pumps during the peak heating hours of the year, where they'll only run during that small bucket of peak hours. And the first dollar cost per BTU of a boiler is quite a bit less than a heat pump, so it can save you there on cost. And it can also allow you to avoid turn down issues with your heat pumps, and so they don't have to turn down quite so low during the shoulder seasons. So I guess next in line are air-to-water heat pumps. These units give you a little more efficiency because instead of creating heat now, you are moving heat using the vapor compression cycle to take heat out of the air and put it into your heating water source. So moving heat like that versus creating it allows this equipment to get you COPs between like 2 and 5. At design winter temperatures in the Sacramento area, typically those units will drop down to a COP of like 2.4, but on average they'll come out to around 3. But there are a lot of different types of air-to-water heat pumps. To start, they can be modular or packaged. Modular units typically have a little bit better turn down. Each module typically has multiple compressors, and the modules can stage on and off as demand goes up and down. And a package unit is more like a traditional air-cooled chiller. It typically has a couple of compressors. They can stage on and off, and or they could be variable speed compressors as well. Air-to-water heat pumps also have the opportunity to be 2-pipe or 4-pipe machines. 2-pipe machines can produce heating water or chilled water, but not at the same time. But 4-pipe machines can simultaneously produce heating water and chilled water, and they can do heat recovery. So if the heating load and cooling load isn't balanced, the air can be used as an additional source to either pull heat from or dump heat into the air. And that is what allow your air source heat pump COPs to get up to like 5 and sometimes even higher than that. And we have a slide specifically on heat recovery on a different slide coming up. But the downside to air-to-water heat pumps is they're kind of like air-cooled chillers. They're large, they're heavy, and they need to be outdoors with access to the air as a heat source. And this means it takes some creativity to utilize these on existing buildings that are currently set up with a gas boiler tucked into a closet that's somewhere that's small and it's lightweight and quiet. Another downside with air-to-water heat pumps is you don't really want to design them with a supply temperature above 130 degrees or so, and I'll talk a little bit more about that on the next slide. The next up on the list are water source heat pumps. These are similar to air source heat pumps, but instead of pulling heat out of the air with the vapor compression cycle, this equipment uses some other water source to pull heat out of. This doesn't necessarily work on every project because you need a water source with enough heat in it to make it work. And your water source can be a lot of different things. Most recently, I've seen projects using campus chilled water return loops as that water source. You pull heat out of the chilled water return to generate your heating water, and then that can actually allow you to provide your building with chilled water as a byproduct on the other side. There are a couple of projects in San Francisco that I know use the water in the bay as a source. Some other less common options are like a nearby pond or something, groundwater, or even sewer water can be used. But whatever it is, you just really have to make sure that the source is available year-round to make sure you have heat when you need it. So this equipment can get you higher efficiencies than an air source for a couple of reasons. One, it has the opportunity to generate heating water and chilled water simultaneously, which is a plus. 2, it's easier to exchange heat with water than it is air. And then 3, typically your water source is at a warmer temperature than ambient air temperatures. For example, in Sacramento, instead of having to pull heat out of like a 40-degree Fahrenheit ambient air, you can pull heat out of like a 50-degree chilled water return or something like that. But lastly, and I know I've talked a lot on this slide already, are the ground source heat pumps. And these are pretty much water source heat pumps with a hydronic loop on each side of the heat pump. But this time the heat for your water source actually comes from the earth. And this obviously isn't always an option, especially on retrofit projects where there isn't enough land available. But when it is a possibility, it's very efficient. You can exchange heat with the earth in either vertical or horizontal loops. The vertical bores go down hundreds of feet, like between 150 and 400 feet down. The horizontal loops are typically only like 15 feet deep, but take up a lot more square footage. And then using the heat from the earth gives you a very steady temperature year-round to either pull heat from to generate your heating hot water or to put into when generating chilled water. So that is another option as well. So a big question that comes up with these new systems, especially on retrofit projects, is what temperature heating hot water to use. Traditional gas boilers, like we all know, are typically set up to use 180-degree Fahrenheit heating water. So here you see a graph on what temperatures air-to-water heat pumps can give you and how their efficiencies change with changing ambient air temperature and supply water temperatures. So there are definitely similar graphs for water source heat pumps, but that compares it to water source temperatures. And so there's a couple of takeaways from this. One, you can see here that the lower supply temperature you go with, the more efficient it will be. So 113 is more efficient than 122, 122 is more efficient than 131, and so on. And then, I guess 2, air-to-water heat pump equipment can technically give you 140-degree supply temperatures. But most manufacturers prefer you to design around 130 degrees just to avoid pushing their equipment as hard as they can go. In new builds, new heating coils can be selected around these lower temperatures in buildings without a problem. But on these retrofit projects with existing coils and piping and all of that designed around 180 degree supply temperatures, these temperatures can become a problem, these lower supply temperatures. However, from what we're seeing, existing heating systems in older buildings tend to be oversized a lot of the time and can actually handle lower supply temperatures some of the times. So a good first step that we've been recommending to owners is to see if their building can handle lower temperatures. Reset the supply temperature in the winter of your heating hot water and see how long you can go or how low down you can go before your rooms can't maintain that set point anymore. And maybe you'll find that only a few zones have issues and you can actually limit your coil replacements moving down to these lower temperatures to just those specific zones. However, there are obviously projects where these temperatures won't work without resizing your building's heating water piping and replacing heating wire coils. There is some hope, definitely, that CO2 heat pumps or heat pump advancements will become available that will give you higher supply temperatures from air-to-water heat pumps, but they're not that common at this point. So the option that is currently available to do higher water temperatures is figuring out a way to use water-to-water heat pumps to get you your supply water temperatures up to around 165 degrees Fahrenheit. And so that's kind of what's shown here. If you have a good water source to pull from, you don't have to do what you see on the screen here. You can just generate 165 degrees Fahrenheit from whatever your water source is. But if you don't have a source, you can actually kind of, in a way, create your own source to allow you to get a higher heating water temperature for your building. So this strategy is starting to be known as like a cascade system or a booster system. So on the screen here, it's just a simple diagram of what this looks like. On the left, you have air-to-water heat pumps operating at a very efficient condition to create your water source. And then you have water source heat pumps that generate your building's actual heating hot water temperature at 165 degrees. So this solution obviously does cost you some overall efficiency because there are multiple stages of heat pumps operating, but it can help owners avoid changing out existing piping and coils in their building, which can be a huge cost saver. So there's a cost of going with this type of system. You pay upfront for the additional equipment. It's a little bit more complicated. You sacrifice some efficiency because you're running more equipment, but it does have the value of reusing your building's existing heating water piping and heating water coils, which could be very significant value depending on the application. So if you go to the next slide, this slide shows that same concept of the booster system, but this time on a much larger scale. And like I mentioned before, this system is called a Cascade system, and it can make a lot of sense specifically for campuses. If your entire campus is designed around 180-degree heating water, switching over to 130 heating water could be a ton of work. So using a large-scale Cascade system to switch that system over to 165-degree water instead of 130 could save you from the vast majority of upgrades that would be needed at the building level. For example, we're looking at a campus right now that has 23 buildings on it, and all of them are set up for 180-degree heating water. So changing out the coils and the piping and all of those buildings to accommodate 130-degree heating water could be a serious challenge. Not to mention just the increased size of the distribution piping that would be needed to get water to those buildings. But in this configuration, you have a condenser water storage tank that acts as your water source, and hopefully you can charge that tank most of the year using your centrifugal chillers. So instead of your heat, rejecting your heat from your chillers to cooling towers, you can capture and store that heat in the condenser water tank. And then you use water source heat pumps to extract heat out of the condenser water tank, and you can generate 165-degree water with those pieces of equipment. And if this system was being used for a new building or a new campus, then you could use the same setup, and instead of providing the 165 degrees, you could drop that down to more modern temperatures of 130 or even 120-degree water at a higher efficiency. But in peak heating moments, where there isn't enough heat from your centrifugal chillers to charge that tank, you can use what they call trim air water heat pumps to charge that tank. And again, at very efficient temperatures. I also show here, if you are limited on space or you want a backup for your trim heat pumps, you can have a portion of that trim heat as gas boilers to help provide that trim heat source. And then that would give you a partially electrified system where you're most of the time relying on electric systems. So one huge benefit in this system in general is that it provides time-independent heat recovery. In Sacramento, in this climate especially, there are many days of the year where you need heating in the mornings and cooling in the afternoons, but not necessarily at the same exact time. So this system allows you to store heat and use it later when you're cooling and heating out. Demand hours aren't necessarily aligning at the same time. But yeah, with that, I'll hand it over to Andrea, and she can talk to this next slide.
Yeah, thanks, Jacob. I think the theme I'm going to continue to echo on is just limiting the invasiveness associated with any of these large-scale campus electrification projects. So the strategy that I'm going to be covering is nodal plants here. As Jacob mentioned, when we're looking at campuses that are on big distribution networks serving 20, 30 plus buildings at a time, it can be a pretty intimidating upfront cost to have to electrify at the heart of the central plant and then look at all the downstream impacts associated with piping replacement or coil replacement. So one of the things specifically we've been looking at on the Glumac side and working with different ownership groups is creating nodal plans where you can cut off a subsection of buildings as seen here, and do a smaller centralized plant serving a cluster of buildings rather than relying on the original location of the main central plant. So this specifically was a case study we did with Sacramento State where we were asked to look at electrifying their library on its own and providing some kind of localized electrified equipment either at the library's roof or at ground level. But one thing we brought up to our client group is potentially the benefit of using this nodal plant strategy and clustering this group of 4 buildings here. And really there's 3 main benefits when I'm looking at this strategy here. So the first one being is allocating a decent amount of space up front to serve multiple buildings rather than trying to do a spatial allocation for all 4 buildings, which can be quite challenging, as Jacob mentioned. A lot of former gas systems are usually indoors and tucked in smaller closets, so having to use technology like air-to-water heat pumps that are in new outdoor spaces can be pretty challenging to allocate on existing campuses. The second piece is utilizing clustered buildings with maybe different load profiles to try to encourage simultaneous heating and cooling. So in this example, we suggested clustering with the University Union and the Resource Center here, which had commercial kitchens and data centers that required more year-round cooling to help supplement when the rest of these buildings are in heating and optimize our chances for heat recovery. And then the last big piece here is being able to cap major pieces of the steam distribution network. So as you can see, we could have capped this steam distribution line back here because all downstream buildings would instead be served off a local centralized plant for this cluster of buildings. So a really cool opportunity and consideration to help phase out the different upfront costs that are hitting ownership at a time rather than tackling it all up front. The next piece that we're going to dive into is focused on heat recovery. So just starting with a brief definition, we like to consider heat recovery as a strategy being used to decrease the energy demand for heating and cooling within the buildings by recapturing what we typically refer to as wasted heat or energy. And specifically within heat recovery, I like to think of a handful of methodologies. Probably the one most of us are familiar with is anytime you have a simultaneous heating or cooling load across an annual profile. But that doesn't mean that's the only opportunity for heat recovery. There's opportunities to introduce false cooling loads to help the building have more simultaneous loads. And then there's some unique applications where you're actually able to recapture rejected heat and repath it into an alternative system. On the next slide, Jacob's going to touch on this with domestic hot water and specifically hybrid heat pump water heaters. For this side specifically, I just wanted to focus on simultaneous heating and cooling loads, specifically because there's a lot of challenges with these existing buildings verifying this annual profile because a lot of these buildings are aged and there's no monitoring systems currently in place or advanced metering to help trend these systems and identify when there truly is a call for heating and cooling demands within those buildings. So a couple of methodologies that we on the Glumac team have found successful is working with ownership and the utility to procure past utility bills to help build trends beyond even a year profile, maybe dating back 2, 3, or even 5 years of data. And then sometimes with the utility bills not being enough information, we've even considered doing simple energy box models to help build the profile and how we'd anticipate these buildings to operate. Another point I just wanted to illustrate here on the heat recovery slide is not to be dissuaded if you don't have a simultaneous load year-round. A lot of times there's opportunities to take advantage of heat recovery in shoulder seasons alone. So on this graphic here, you can see simultaneous load in the shoulder seasons, which is your early spring, some parts of summer, and then fall. And what I think is really cool is technology like the 4-pipe air-to-water heat pump has the opportunity to operate in either or mode, meaning when there's no simultaneous cooling, these units can operate in heating only mode, and then in those shoulder seasons, take advantage of simultaneous load and operate in heat recovery with the same piece of equipment. So I think really helpful when we're evaluating heat recovery on existing buildings with already limited space for new equipment. In this example I have here on the screen, I think another great aspect of this system is it's interfacing with existing chilled water plants with minimal invasiveness on how that system is operating on its own, and you're able to interconnect systems that have traditionally been independent. The last piece I just wanted to touch on here with heat recovery is really making sure we validate payback for the ownerships and clients that we're working with. As I mentioned, you don't necessarily need to have simultaneous heating and cooling load year-round, but you should be performing some kind of life cycle cost analysis to validate that those more expensive heat recovery machines are actually able to operate in their points of higher efficiency and help with reducing those lower operating costs to assist with payback. So that wraps up the heat recovery slide. I'll turn it over to Jacob, who's going to wrap up this technology review with domestic water heating.
Yeah, thanks. And I won't spend a ton of time on this slide. It'll be pretty similar to the heating hot water technologies in general. But this is set up in the same way as that previous slide and shows the different options amongst domestic hot water systems. But if your building doesn't have a huge domestic hot water demand and it's more of just an office space without showers or locker rooms or kitchens, you can go with one of the two options on the left that just use electric resistance to heat your water. If your demand is larger than that and you want a more efficient system, you can go with a hybrid heat pump. And the hybrid heat pump pulls heat out of the air and puts it into your domestic hot water. It also has an electric resistance that can be used as the backup for that. And so one of the benefits of going with a heat pump like this is that you can get some quote unquote free cooling for your building. So say you put this unit in a mechanical room with a bunch of pumps and air compressors and other equipment that lets off a bunch of heat. This type of water heater can cool that space for you while making your hot water. However, similar to kind of what we talked about before, you have to make sure that you have a significant enough amount of a heat source in that room to avoid freezing out your space and forcing that unit to trip over to electric resistance and running on electric resistance heating all of the time. So if there's not enough heat being naturally generated in the room that you use as your source, you kind of have to get creative with that. For example, I've seen some people dump the cold air, actually duct it back into the return plenum and things like that to make it work. But then the last option on the right is for buildings with more significant domestic hot water demand. So this is a very similar concept to the last one, but you have an outdoor unit now grabbing that heat from the outside air, so you don't have to worry about overcooling a space. There are also opportunities to produce domestic hot water from the building's heating hot water loop in your building. But you need to keep in mind that you need to have a hot enough heating hot water loop to be able to do that. So if you went with a 165-degree heating water system, you can do that, but you're not going to be able to do that as easily if you went down to 130 degrees. And you have to be careful if you do that because it can restrict your setback temperatures on your heating hot water loop. And if there is a desire to eventually drop that 165 heating water down to 130 or something like that, you'll have to figure out a whole new solution for your domestic hot water at that point. But I know, Ryan, you had some experience with domestic hot water systems. Did you want to add anything here? Any creative solutions that you've seen on the domestic hot water side?
Yeah, so there's, to illustrate this kind of elegant form of heat recovery, there's a particular office type application I've seen in our territory that scavenged. The heat pump water heater was installed next to a hallway, and the hallway was about, say, 15-foot tall ceilings, higher than the rest of the building. And the transfer duct was placed, the grill and duct were placed high up into that hallway space, drawn into the room with an exhaust fan. And then the exhaust fan discharged that cool, dry air into the return air plenum, and it relaxed the central systems. And I think it's important to note that the domestic hot water load and space conditioning loads aren't necessarily coincident, but it just helps take the edge off, which is sweet. Thank you.
Yeah, thanks, Ryan, for adding to that. Yeah, that's all I had for this slide.
All right, awesome. Well, thanks for sticking with us through general technology implementation. The part I'm really excited to share today is specifically how Glumac, the county, and SMUD all started working together on a variety of projects through SMUD's electrification and energy efficiency incentive program. So I'll pass this over to Raleigh and Ryan.
Yeah, so this is really cool. So right before I got hired with the county, Glumac and SMUD were already talking about a couple facilities that basically they had coordinated with our energy program manager. So, and I saw the results of those studies, helped kind of assess them with them after I had got hired back in early 2023. So Glumac studied 3 buildings for the county, all 3 pretty poor forming like energy performance when it comes to natural gas usage. And so these facilities were the primary care center. So the county has basically it's an unlicensed medical clinic, but it's got a lot of like laboratory facilities as well over at Broadway, kind of in the Sacramento City area. Just right next to it, we have our coroner and crime lab. So that facility holds our morgue, it holds our crime laboratory as well. And then then there's a third building. It's our sheriff's administration building. That one's located more downtown. It's got a lot of admin facility in it, but there's a bunch of social services that happen there as well, and a bit of behavioral components. So really interesting places. Generally, so you can see here, we've kind of got our electrified solutions that were presented. This is kind of a high level approach for what was done for these facilities, presented by Glumac and kind of given to us via the report that SMUD delivered. And generally, Sacramento County really liked a lot of the out-of-box thinking that, frankly, some of it I was unfamiliar with. And I know Jacob and Andrea already kind of talked about the technology we've been focusing on. But for example, for me, like I was doing MEP design for the past 8 years, and I was totally unaware of the Cascade booster systems. And I felt like those kind of systems were really elegant for handling some of the more traditional hot water temperature systems that are ingrained in these buildings. You know, the fact that you can have this older 180 degree, sometimes even 190 degree system, and you're trying to bring in this heat pump water heating system that might be really targeted at, I know, delivering 140 degree temperatures, and you could bring in just this supplemental downstream in series unit to boost that water temperature up, I saw as a potential huge win, because that keeps us from upsizing all of our infrastructure, like the hot water piping. Specifically, like I remember looking at the Coroner Crime Lab and seeing all the spidering out of all of our hot water piping to the hot water coils for air handlers that are custom, built into space, tiny little closets. We had VAV boxes, that coils that would have need upsizing. So it was kind of a nice way to, you know, from a design perspective, you can zoom out a bit and sort of brute force the old system into being electrified. Actually, I mean, before we kind of talk about some of the downsides to that, I know Ryan wanted to talk about the electrification kind of assessments. You want to talk about that, Ryan?
Yeah, so diving in on the, so with this, so SMUD offers electrification assessments for customers in our territory that are exploring complex electrification measures for their buildings. And there's a couple of, so these 3 projects shown here went through that process, and it was actually super wonderful. To kind of share a little bit about that process. So we offer these free assessments for customers, and what they do is, it's just to highlight this, 2 kind of conditions for these assessments would be that it's a complex electrification measure, like a water-to-water heat pump, air-to-water heat pump, etc., and that the intent is to move forward with the project. And we recognize not all projects move forward for various reasons, but what results is this high-level scoping study that the customer and design team, they can discuss further, take further, and it provides guidance on proposed systems. It gives a very high-level equipment layout, shows clearances, and offers potential solutions. And to be fair, if the design moves forward and a future design team gets a hold of the study and they look at it, they might even look at the solutions and say, you know what, none of these work, but you've jogged my memory and my imagination, and this other system will work. And that's really the goal of these assessments, is to continue conversations and provide solutions. Thank you.
Yeah, no, that's a great point, Ryan, because I'm about ready, if you want to go to the next slide, good, Andrea, to kind of launch into sort of the downsides of us having the studies for these facilities. So I'll only kind of spend a brief moment here. So, you know, we have these feasibility studies, and quite frankly, the county wasn't really prepared to jump in and take measured changes at these sites. So critically, all these sites that were studied, yes, they were poor performers, but they also weren't great candidates for this emerging, well, some of this is more tried and true to electrification technology, but this booster pump system, for example, which we were seeing as like something that we could apply in a lot of cases, not the greatest candidates for it. So we kind of listed a few things here. So a lot of these were high security sites. They had challenging access both on the ground. They were built into place with other facilities around it. So we didn't have a lot of great grade mounted locations to bring in a bunch of new central equipment. If it was going to be located on the roof, it would be a pretty sizable, you know, structural assessment. And then we could already tell we would need significant structural upgrades the buildings to handle these larger boxcar shaped pieces of equipment that then sit on the roof, make a bunch of noise. Noise concerns are kind of its own thing there too. All these were critical use facilities, so like the crime lab, the primary care center, and a lot of the social service pieces, a lot of them really needed to run 24/7, and the user base within these buildings were way more dependent on having solid heating and cooling needs for the facility. And not that we couldn't push them and pressure them, but just there wasn't a huge amount of appetite to take that on at these sites. Kind of on the other end, we engaged our maintenance teams, and at the time we kind of had our facility manager and our lead stationary engineer take a look at these sites with us, and immediately we kind of flagged these as like really challenging spaces to serve and to maintain because they were further away from our field maintenance hubs, and so that wasn't as attractive to try to dive into those. And then the biggest thing were like the costs. I mean, you know, from many of you who are probably on the user side, like infrastructure costs of paying for something like this is always top of mind, and these were not light changes we were looking to make. And on top of, I believe we were making changes to facilities, proposing to make changes to facilities on equipment that wasn't yet fully depreciated. So what we did instead is, I mean, we took a lot of the lessons, the types of technology that was proposed, we took a lot of those lessons to an alternate site. And so what we've got here is an image of the branch center district. So, you know, Sacramento County is kind of divided up into a couple different kind of quadrants. Branch center, which is off of 50 to the south. We have about 15 or 16 buildings over here. And the north core 4 of these, one of them is the building I'm in, has a bunch of old aging HVAC equipment. We have all these, they're all served by chillers and boilers. They're not as critical sites. I'll go ahead and kind of list them. We've got kind of the branch center building, which is 3,700. That's kind of a mix of IT space and warehouse. We have office building number 3. That's a health and human services building. It's a multi-floor building, but a lot of it is admin features. We've got a real estate building as well as 9660 Ecology Lane, which acts as kind of like our contracts and purchasing building, and is where we sit over at architectural services. So yeah, these facilities were much better candidates because, again, they're not as critical sites. A lot of them had some component of 24/7 operation, but really there wasn't a public access side where that was as big of a concern. And, you know, temporary reductions in the critical cooling and heating wouldn't likely impact the users in a major way. It was much closer to our field maintenance operations hub, which is just one building to the south of us. There's like a big lot between it. You know, you can walk there from here. And then, like I said, a lot of the systems like the boilers and the chillers, we already had existing requests to replace them on. One of the building in particular, office building number 3, actually has this like oversized chiller where it's end of life, but we have to replace it soon because we anticipated some future loads there that aren't really turning out. And so all of these pieces, along with having these kind of larger lots available nearby, gives us more flexibility to kind of put in central equipment, made it a much more attractive kind of place to look at. And so, and on top of that, we had smaller downstream impacts. So half the buildings on these facilities weren't served with like integrated piping that runs to the building that potentially needed to upsize. A lot of them are dual duct facilities where we had these large air handlers located on roofs where we're delivering hot air into the building, but if we had to potentially upsize hot water coils or swap out piping, it's exterior to the building and somewhat less invasive. So, you know, I think mainly the takeaway for something like this is, you know, when we're engaging on studies, it's really important to get like the stakeholder interests involved and make sure you're studying things that are kind of important, and also kind of reaching into like, if we're going to make recommendations to swap equipment out, we probably should be looking at the stuff that's already kind of on the docket to get replaced pretty soon anyways. So from here, I'll kick it over to Jacob, who's going to talk about our electrification approach and how they kind of propose this to the county.
Yeah, and so this was a really fun project to be involved in, and it's still ongoing, so we don't have final results to kind of put forward today, but excited to find out the results of all of that. So, but how we approached this is, so we kind of gave 3 options to Sacramento County to look at from a pricing perspective. The first one is just come in and do a simple like-for-like equipment replacement. Raleigh mentioned that a lot of this equipment was at end of life. So what does it take if they just fixed it? They just put in new equipment to make the buildings operational in the same way they are now. So that was option 1. Option 2 was to take each of these buildings and electrify them individually. As Raleigh mentioned, they all have chilled water and heating water at them. And, or I guess the north building that you're seeing on the map here, the planned north one, does not have the heating water. Those are DX systems. But they all have hydronic heating water at them. And so to do that, each building was given its own hydronic loop, a small air-to-water heat pump. Some of the bigger buildings were recommending a heating electric boiler to kind of supplement that, like I talked about before, where 20% of the capacity you put as electric boilers. And it was tough because these are existing buildings, and you're trying to add a large air-to-water heat pump at them. So we worked very closely with Raleigh to see what locations were they comfortable putting a new air-to-water heat pump at, try to mitigate structural improvements, try to mitigate sound nuisance and things like that. And then option 3 was what does it look like to put all of these on a central plant? So take the chilled water from all these plants, and you can kind of see that in the square in the parking lot there. That was kind of identified as the best location in the middle of all of these buildings to put a central plant. So in that location, put water-cooled chillers, cooling towers, and then provide one large air-to-water heat pump plant as well to distribute that heating water and the chilled water to each plant. And there were a lot of questions that we kind of had bouncing around in our head when we looked at this. One is, do you try to go with 165-degree water, or do you switch over to 130? Like Raleigh mentioned, some of these two of the bigger buildings here have dual duct systems. So the only coils in piping at those buildings are the coils in those air handling units. So really, you're not having to change all the infrastructure that you would in a typical VAV with hot water reheat system, where the piping is going to all your reheat coils, and you have to change every reheat coil, all the piping to all those reheat coils. So in these ones, it was just really the main air handling units at those buildings. And so because there wasn't that much infrastructure associated with switching to 130, that was kind of the route we took on this one, is to do your plant with air-to-water heat pumps and stick with 130-degree hot water. So that was an interesting kind of back and forth between us and Raleigh, and talking about the pros and cons of that decision making. But obviously with the campus solution, we don't have all the pricing numbers back, but there's some economies of scale going with that. You use bigger equipment, are able to serve multiple buildings. It also provides ease of maintenance for the maintenance staff. They can go and they can work on all of the equipment in one area, the pumps, the chillers, the cooling towers, the air-to-water heat pumps. All of that stuff is located in one general location, and they can do the maintenance there. So that was another big benefit of the campus solution approach. There wasn't a large amount, after looking at the utility bills, of simultaneous heating and cooling at the building. So we really went with just simple 2-pipe air-to-water heat pumps for this to provide a separate cooling and heating. And Andre, you can add to that if I missed anything there. But yeah, so that was kind of the approach and how we tackled this, and excited to see kind of how the pricing comes out and what the county ends up deciding to do with it. I know the project is on a little bit of a hold right now because we're investigating how much electrical capacity it'll take to do EV charging as well, because that's another goal of the county, to try to add EV to that site as well.
Yeah, thanks, Jacob. I think this is a good segue to our partner Ryan on the call, because with any of these high-level feasibility studies, we do engage our local utility to get an understanding of the impact for some of these major electrical capacity upgrades.
This is amazing. Thank you so much. So you just worked with an amazing consultant. You've got a rad project coming up, and you're like, next step, got to engage the local awesome utility, electric utility. So the ways that we can support you further with this is not only with incentives to help offset those project costs, but also technical support. And I don't want to underestimate that. Like, I know some folks can think of an electric utility as just interconnection and incentives, but also think of us as that third party to take you further. So what I wanted to highlight was some programs we have here. So specifically, we have custom retrofit, which focuses on existing building system retrofit. So you can think of it as like your boiler being replaced out with a nice air to water heat pump or some solution like that. And offering incentives on both electrification and energy efficiency. Integrated Design Solutions is a program that I personally manage. It's new construction, extensive renovation, more of a whole building design assistance program being brought in early to support the effort. Also offering incentives for electrification and energy efficiency. And on the far right, the Go Electric for Business. So that is our kind of overall website for commercial electrification efforts, and it's a great go-to. There's case studies at the bottom of customers in our territory actually implementing electrification, and trust me, that case studies list that you see there is a fraction of what we really offer. Okay, so yeah, next slide. And now, yeah, never too early to engage us. Okay, so this one's a little bit thick, and I know we're running a little bit tight on time. I know there's a lot of information here. I'm going to try and get through this. What I wanted to share was some existing cup decarbonization considerations. So you've got your existing cup. You've designed it with extra capacity. Any future buildings you bring online, design them to be low heating hot water supply, and that will just future-proof your cup as you further decarbonize it in the future. As other older legacy buildings come offline, and you now have one less building to worry about. Winter is coming. I wish I came up with that saying. It's awesome. So like it was mentioned earlier, run your test before winter starts. Coordinate with your central utility plant facilities, and coordinate that they turn the heating hot water supply temps down, but the goal is no callbacks. You don't want any callbacks, but you want to drive those temperatures down. See where you can go. The reason I mentioned that, and it was illustrated earlier, the lower heating hot water temps you get, the higher COPs you get, the more capacity you get out of your machine, the more relaxed your heat pumps will be, and we all want to be relaxed. You'll get extra life out of the machine. It's just awesome. But I do want to point out, watch the heating hot water return to your non-condensing boilers, because you'll give them a bad time otherwise, so you can coordinate with facilities on that. Where possible, weave in hydronic heat recovery solutions. Why do I say that? So you just purchased a precious kWh from your local electric utility to fire off your compressor. So your chiller, you fire off your chiller, you're getting single duty out of it. Chilled water. You fire off your pipe air to water heat pump, you're getting single duty out of it. You're getting heating hot water. If you can implement a machine like a 4-pipe air to water heat pump, a water to water heat pump, a 6-pipe water to water heat pump, you implement this machine for that single kWh you just purchased, you're getting multiple duty out of it. You're turning a COP of 3 into like 5, 6 plus. It's amazing. So do that. But you want to study your system, because if you already have a chilled water plant, thermal energy storage on, you might have your chiller running where it's non-coincident, and so that would be something you want to study. Anyways, for hydronic heat recovery, and I will jam through this, consider air side economizers on your project, on your buildings, lowering it from 75 to 68 degrees outside air, and it brings up this idea that was mentioned earlier of false loading your central plant. And why would you want to do that? It's a way to recover valuable heat. And then, like Jacob mentioned with the geofield for your system, you could consider a geofield for heat recovery chillers to also false load them. Dump chilled water to recover valuable heat out of the earth. Use that heat into the rest of your campus. Consider thermal energy storage for heating hot water. Trust me, tank capacity is a lot less expensive than equipment capacity. Very little maintenance, very little wearing out. Operational costs are negligible, just pump energy, and it's a wonderful way to go. Plus, so to illustrate that, just concept-wise, if you had, say, 7 air-to-water heat pumps needed for a project, you could, in theory, trim that down to 3 with a thermal energy storage tank. And so you end up with fewer machines. Anyways, it's awesome. Plus, they get to run at a sweet constant load instead of start-stop. As it was mentioned earlier, never intend to operate a heat pump at max rated output. It'll just burn it out and your electric bill won't be happy. Address loads on your cup strategically. What is meant by that? All it takes is one rogue building to ruin the fun of it all. So if you have one building that's acting out of compliance, requires super hot water, requires super chilled water, it's going to ruin the fun for everyone else. So get those buildings commissioned, tidied up. If you find a rogue building on your project, You might be able to address the strainer, clean the coils. It might perform better, commission it. Avoid matching existing equipment to nameplate. So you're looking to make the move forward. Don't get those engineers to match like for like. Tell them, no, you will not do this. You will study the heating, hot water, BTU meters we have and the gas meters we have. We'll get these loads right. Account for heating, hot water supply degradation. Normally for a high temperature solution like 160 or 180 conventional solution, when the water gets out to your building, it's dropped a little bit in temperature, but it still works. Yes, it goes through insulated pipes, but all insulation does is it reduces heat loss. So there's still heat loss. When you're running lower heating hot water temperatures, just account for that. The final thing, and I appreciate your patience through this, for existing central utility plants in general, greater optimization can be realized with a smaller cup, like what was presented earlier with the Nodal approach. Less optimization with a larger cup. And what I mean by that is it's not that optimization can't be realized with a large cup, it's just a larger task to pursue because all it takes is one building to ruin the fun for it all. Thank you so much.
Yeah, thanks, Ryan. I think that's a great summary. Again, just continuing with summarizing, I think each of us has a different lens, whether it's the utility, the ownership, or the design and consulting side. So just wanted to wrap it up with our key takeaways. So Ryan?
Thank you so much. Okay, so that is legit right there. Be sure to engage your utility early. It's never too early. And I want to verify that is almost SMUD orange. If this was a presentation I was giving, I would tell people that is SMUD orange. Take this serious. The reason is it supports interconnection and equipment procurement. The reason that's so important is it helps with project planning. So what happens is we're in an era where transformers and switchgear are precious commodity. I thought gold was legit precious. Turns out these devices are worth more. So planning for it allows you to procure it early, and there'll be no project holdups or minimal, hopefully none. And then plus it helps with just planning overall. The other benefit that we offer are grid capacity evaluation forms. And so what this is it gives you an opportunity to see that truly enough electricity is available for the solution that you are wanting to pursue. What I mean by that is you can look at your panel and say, I've got plenty of room on this panel, just fill that puppy up. Actually, you want to do is you want to engage your local utility and ensure that the transformer has sufficient capacity, and on top of that, all the lines to the transformer. And what you're going to end up getting is a really concise document that illustrates how much capacity is available in summertime, and in this era of decarbonization, how much capacity is available in wintertime. Now, I want to say, don't shed a tear if you're like, oh my gosh, hold on one second, it looks like there's not much left. Well, you might be replacing a piece of equipment on your project like a large electric resistance water heater with a sweet, efficient heat pump water heater. And you can free up that capacity and kind of account for that in the overall grid capacity evaluation. The other, last but not least, is engaging us early maximizes on potential incentives and technical support, and you would be surprised at the value add to that project. And sometimes the technical support, you can't quantify it, but the value is there. So I just want to highlight, want to wrap this up. When the idea for your project comes to you at 2 in the morning, you wake up, you're like, oh my gosh, I'm going to write this down on the napkin on my bedstand. Just write, if you're in our territory, just write 4 additional letters, SMUD, and then go back to sleep. And when you wake up the next morning, reach out to us. We're here for you. Thank you so much.
Thanks, Ryan and Raleigh.
Yeah, so I was thinking about 2 things from the owner side, lessons that we can learn. Number one was generally, and again, we kind of had some of these studies that we didn't take immediate action on, was just don't study things you don't have to. Engage your stakeholders early. Find out, what are your vested interests in the site, age of facilities, prior to you going and running down the pathway. Everyone wants to see people move quickly, but I think, in my opinion, we should be, especially on owner side roles, like make sure you're moving smartly. Does that make sense? The other piece is just making sure you understand your baseline restrictions for compliance in your region. So here in Sacramento, right, we've had these changes. We've got generally over all of us, we've got the California Energy Code code, which has its baseline requirements for the entire state. But now we have a new climate action plan. And so you need to know, what are requirements in your city, in your county that may override or take, local ordinances over what you might be doing traditionally. And if you're not a mechanical engineer, I mean, you don't have to be one to provide that kind of value to your team. Just tell your mechanical engineer, like, hey, are you aware? I'm in the city of Elk Grove. We have a climate action plan. Have you guys considered how you're going to respond to that? And so those kind of things can be kind of surprise gotchas, especially when you fund a project, you move into construction design, you get into permitting, all of a sudden you've got, oh no, I've got all these requirements for my facility. I don't even know if I can design that natural gas boiler, right? And I thought of a bonus one that we didn't get on here was, and this has kind of hit me a couple times, is weasel your way if you can, and if you have that kind of positioning, weasel your way into like initial programming and schematic design meetings, and just start to drop the nuggets of like, why can't we electrify? There's been a couple key projects, even I've been at the county just now for a year, that I was able to kind of get some assessments in and say, oh, why are we not doing electrification for this, this project here? And I realized like, oh, the consultant's already on contract to design a gas system. I didn't get my say in earlier enough, and I'm already kind of locked out. And it's hugely disappointing. But I realized if I probably had the availability to kind of get into those conversations and say, hey, you know what, we're moving towards a climate action plan. We really should be considering electrification for this new facility we're constructing, or this kind of retrofit. And the earlier you can, kind of similar to SMUD's kind of comment, the earlier you can get in there and drop those goals. Once those get written into like the meeting minutes, they start to get kind of locked and moved through the project, and there's always this baseline assumption that you're electrifying. So kind of just consider that, or drop it into your consultant engineer's kind of mind is like, hey, the county wants to consider that. Please don't drop that, right? So that's kind of the ownership side.
Awesome. Thanks, Raleigh. And then Jacob on the engineering design side.
Yeah, well, I love all the takeaways so far from this. From an engineering standpoint, the first one here is existing heating systems are typically oversized. And what I mean by that, sometimes they installed a heating system a long time ago, they rounded up to the next traditional boiler size or standard boiler size. And since then, they've done envelope improvements. They've done a lot of things to the building to make it run more efficiently. And sometimes those systems are just very oversized. So take the time to look at the meter data, or do a quick load calc before you just match the nameplate size. And I know, Ryan, you already mentioned that. Andre, you want to take the second one?
Yeah, this one's probably my favorite, that partial action is better than inaction. I think a lot of times, a lot of us working towards electrification and decarbonization are daunted by those upfront costs. And I've been in no shortage of meetings where funding is the limiter on the design, but that's not to say we can't do nothing. As a consultant, we can do a lot to help our clients get electric ready. We can do a lot, as Raleigh mentioned, to help dovetail with projects where equipment is already due for replacement, and helping dovetail electrification projects with end of life. And then we can use our data-driven design tools as consultants to inform partial electrification and how much of a heat pump to use versus retaining some of your original gas assets. So lots of things we can do there on the consultant side. Pass it back to you, Jacob.
The third one is identify retrofit or technology non-starters with your clients early. I think that's just have the open dialogue in between with you and your client. Make sure that they're okay with any technologies that you're proposing, that their maintenance staff has the ability and desire to want to take on a new effort and stuff like that. Because these technologies they're more complicated than the traditional boiler systems that they've been working on for years. And then the last one is use your equipment vendors. This heat pump technology is advancing really quickly, and every heat pump has different system requirements in the way it operates, minimum flows, minimum pressures, how it responds to your pumps, whether it wants to be variable speed primary or primary secondary pumping scheme. So just talk with your vendors and really build a close relationship with them so they have a lot of say in how the system's going together.
Awesome. And that takes us to the end of the slide deck. So Joey, I'll hand it back to you.
Awesome. Thank you so much to our full panelist of instructors today. You've dropped a ton of information on us, and there's probably a number of questions circulating through folks' heads in the audience and how to form those questions. While those questions eventually come in, I'm going to ask one of my own. You've done so well, I don't see anything in the chat, and I'm probably not nailing this on the head myself. But I remember earlier on, Jacob, you had a slide that was sharing a design that included a natural gas boiler to help trim during peak heating times. I was hoping that you might be able to chat and provide some guidance on when you, as the consulting engineer, might come to the table and support including a gas boiler versus an electric resistance boiler. And maybe you could touch on some of the major considerations that dictate, do I even need this trim heat source? Like, is there a circumstance where I don't need that? That's really just a 1% scenario. And then what are the major upfront costs that go into it? Yeah, it's a 1% scenario. How much more is that going to trigger me to have to spend on that? And then are there any strategies that I may be able to implement that helps mitigate those costs? So sorry to give you the classic, what I'd call the SMUD interview question with 5 different parts on that. But I was just hoping to circulate a little bit of thought around that consideration, because it's not something that you think about until you really get into that design phase and start saying with a what if scenario.
Yeah, I'm going to try to hit all of those 5 sub questions, but if I miss one, definitely remind me. So the natural gas boiler. So this is showing the centrifugal chillers, when they have load on them, they can reject their heat to the condenser water tank. When there's not chilled water load in your building, you don't have that heat to reject to your tank. And so that's the case where you would need trim heat. But say your building was a data center and you had all of the free heating that you needed from those centrifugal chillers because you have year-round load. It's cold outside, but you still have a ton of heat coming from servers in your data center. Those centrifugal chillers are still going to operate, and you're still going to have those chillers charging your condenser water tank. But if you're a typical office building or a school building where there's not that 24/7, 365 heating source from the chillers, then you probably have to use trim heating to get that heat source for your condenser water system. In the natural gas / electric boiler, I mean, you can use either or. One of the limiting factors is obviously electricity. It has to be coming into your building from somewhere. So say you're already tapped out of your electrical capacity and you approach SMUD, and it would be a big project to add the electrical infrastructure that would price the project out, and they wouldn't do any of this electrification because of that limiting cost factor. Then maybe just using a natural gas boiler on that piece makes sense. Maybe that saves cost of the electrical infrastructure upgrades. Maybe they don't have enough room to put those air-to-water heat pumps. Maybe you're on a restricted site and you just don't have the land available, the space. We run into that all the time, especially in like downtown facilities where you're just out of space for air-to-water heat pumps because they are big and loud. You can always, but you could use the electric boiler, but then does that put you past your electric resistance or your electric capacity that is at your building? So that's kind of, did I miss anything that you may have asked in that question? Did I hit on all those?
You're doing a great job, Jacob. Yeah, that was the bulk of what I was looking for, and you nailed it, nailed the points I was thinking of and have come across as well. So thank you very much.
Yeah, great. Thanks for the question.
Yeah, you bet. And it bought us a little bit of time so our audience could put some questions together in the chat. So I'm going to go from top down on this. What is the customer's experience like with a SMUD representative during the initial assessment? What boxes are being checked before equipment selection is discussed? And maybe Ryan, you could take that one at first.
Yes. So I hope I'm understanding the question correctly. So engaging us early, like for a couple prongs on this. Interconnection will request a electrical load from the electrical engineer, and that's assessed like based on diversity, assumption applied to equipment and the equipment types, etc. And that'll support that process. And then with the incentive programs, we'll want to check with you on potential solutions and such, in hopes of ultimately reducing the interconnection load. I'm hoping I'm interpreting this question correctly. And then what boxes are being checked before equipment selection is discussed. So it's kind of a multi-discussion. So it'll be with the design team on equipment and with course, then there's electrical interconnection equipment. So I kind of answered that. Anyone else wants to chime in? Yeah.
Awesome. Yeah. Anyone else wants to chime in?
I
sure
could say,
Glumac-
like, you know, for the county side, we often act as like in that customer role, if you will. And I mean, there are some baseline things we're approaching SMUD with when we do it from our perspective is like we'll have Glumac or somebody similar to that present some sort of selection for us, sort of a pre-design, if you will. And then when we're submitting that to the county, it's relatively easy. I mean, the relationship the county has with SMUD is pretty tight. And so I don't actually have to fill out a lot of forms. I can just say, hey, here's our plan. This is the transformer, the service we want to look at. Can you tell us about our remaining capacity? And someone like Ryan or John Barnes over at SMUD has kind of just produced these electrical assessments for us to tell us about this remaining capacity. It's kind of easy. The challenging part is once you realize like, oh, we actually need to upgrade your service or we need to upgrade your transformer, and then do we want to collect costing on that? Does that impact our report? So the spin-offs, the falling out of that can be kind of unfortunate to hear, but it also can be good too, because it depends on exactly what sort of options you're using. Maybe it wants to kind of impact the actual selections, the items you do. There probably is a bit more formal process on the true customer side. I think, again, the county has kind of some inroads within SMUD to kind of make less friction, but even then the SMUD seems super open and easy to have those kinds of assessments done.
Yeah, and I'm going to throw in a little plug for our friends on the account management side. If you're one of SMUD's commercial industrial customers, you have a dedicated strategic account advisor within SMUD, and they're I'm going to call them your conduit directly into SMUD. You have someone that is meant to know all about your account, about your business, and help you through these processes. And in the case of a project like this, the SAA, Strategic Account Advisor, would direct you to, in this example, Ryan Hammond's program, where an integrated design solutions would support you from there. So part of that experience is, of course, the fact that we have those people on staff to help streamline that experience with us. I'm gonna thank you, Raleigh. Thank you, Ryan, for answering that. I'm gonna jump to another question, which is about what kind of technology is actually out there and available. Do they make heat pump water heaters with remote? And I'm going to merge the two outdoor units.
Can I take this one, Joey?
Hey, fire away, Raleigh.
Hey, because the person who's asking this is currently our stationary engineer lead for a lot of the facilities in the project district. And Rick, you have yet to see actually kind of an actual application of the question you're asking. So one of the sites that Glumac studied for us was the domestic hot water, industrial hot water system at our Corners lab. That project needs to be moved kind of a bit more quickly, and so Glumac has kind of put together a design for the county for that, which does exactly what you're stating. Some of the options proposed are single pass heat pump exchangers, that exactly what we're circling there, units that are located at the roof, which rejects that heat out into the world, or sorry, rejects that cooling, out into the world, doesn't really impact the boiler room that's situated, I know you know the facility, right there below in that mechanical room. I was a part of some of those designs when I was working at Peters. We would often do this for larger domestic water systems, like Colmec's a good example, but there are others where you can kind of just string together a bunch of single pass heat exchangers, pump it into like a lead storage tank, and then you have a number of single series storage tanks behind it. And often that kind of lead tank acts as, I want to say, Jacob, you probably know this better terminology, but like a swing tank. I'm not much of a plumber, but I think there's like a swing tank in the front, which kind of helps you maintain that like nice, juicy, like 140-degree water, 135 to keep you away from like Legionella. But it's becoming more common, and I'm advocating for that at, again, one of these critical sites that we've been talking about, because this technology has been seen in a number of places. It's more vetted out. I feel more confident even giving it to our users who care for 24/7 operation, especially because you can size out these single pass heat exchangers with an N+1 technology. You can do like an extra one so that if you have to put one down for maintenance or one breaks, you don't lose all your capacity.
Let's try unmuting here. Thanks, Raleigh. Anything else to add from our other instructors on that one? Awesome. So we're at time, but I'm going to leave this open as long as our instructors, I'm going to look for a nod or okay with going a few more minutes. If you're willing to stick around with us, we'll answer questions as they come up. So next up, my good buddy Larry, golfing and former customer of mine, maybe current customer as well. What grants and funding sources are available when the government keeps taking our funding away? It seems like the Trump administration isn't going to provide funding and the state won't pop for it, but have these mandates we're supposed to adhere to. So I could say SMUD is going to stay the course on this one, and maybe Ryan, you could piggyback off of this comment so we can speak for ourselves on this, and say that, you know, we're committed, and our CEO continues to fortify his stance that we're committed to this zero carbon plan, and we're going to keep going with it. So we can speak for ourselves. I'll also share that I'm doing a lot of work with the likes of iBank, Go Green, and CalCap, who are backing financial institutions to bring financing mechanisms to the table to fund decarbonization measures, even those that haven't been traditionally financed through what I'll call on-bill financing programs, or those that have a typical payback required by financial institutions. So that's a minor plug for what's going to be a future course that's in formation right now. So first, I'm going to have a training for the banks and the financial institutions to learn from CalCap, Go Green, and iBank about those products that they have. And then I'm hoping those banks will come to the table and offer the training about the products that they have in order to pay for these. So I think that's sort of my time frame from an education perspective. But those are already out there, just not so much at the local or regional financial institution level. You're really looking for some of the big institutions to take those risks on right now. And that's just practically how Go Green and CalCap have been doing their outreach and targeting, is taking on the big fish first and moving down from there. Andrea, I saw you nodding on there. Is there something else that I should have added on that question as far as funding? Because you probably know better than I do how to put the package together.
No, I would say that's very similar to what we've been seeing on the statewide decarbonization we're doing with DGS. A lot of those programs you mentioned are still active for the state, but like I said earlier, it's active monitoring situation for all of us in the industry to see how some of these previous incentive programs will be impacted.
Yeah, we're watching that closely as well, and I actually have a dedicated class. We're working with Plugged In America to talk about the impact that the Trump administration is going to have on EV incentives. So that's going to be coming up in April. Plugged In America has an office in DC, so they're monitoring it really closely and are providing us as real-time information as they can get, so that we can also educate our customers on what's out there. The same will be true for like IRA funding and incentives that are out there for these types of measures. As it comes up, I'm going to do my best to get that information to the forefront. So thank you. I love the Weasel JPEG, by the way. I downloaded it immediately. I'm going to see if SMUD brand will let me integrate it into my background. So thank you for sharing that. Yes, electrification for life.
Yeah, I also want to comment, kind of, Joey, if you want. I mean, this is kind of a touchy topic earlier, kind of about like the grant funding. So like Sacramento County, you know, within the county, there's some sources for grant funding they're relying on. I know, for example, we haven't talked about them today, but I've got some projects that are, I think it's Inflation Reduction Act money being geared towards our public libraries, which are replacing aging facilities. Now, those grant fundings, they're targeted for upgrading filtration on some of our systems, but I'm also using it as an opportunity to, why don't we also electrify those facilities? And the grant wasn't specifically targeting that, but SMUD is giving us incentives. We're in some cases getting almost $100,000 for the county. It's free money, right? For us to go and incentivize that pull. And in all three of these facilities, we're doing, actually lately, we're going to be doing Carmichael Library, Art and Dimick Library, and North Highlands. All three of those libraries are basically, the delta between what it costs to electrify that is completely being paid for by SMUD incentives, which is hugely valuable. Now, it is grant funding, and it's not directly tied. I think it's already allocated for that facility. The challenging part of this conversation is like, oh man, how do we, all these other projects we're talking about, larger infrastructure projects, and the county's kind of having some developing conversations of what we will do. We're trying our best to kind of go across the gamut of the sources available, but it is a huge challenge, and right now it's not super clear. The one thing I'll say with our cap is, the cap is an aspirational goal. This might sound bad. There's not a ton of teeth in there for if we fail to meet our carbon emission reduction goals, but things may change with that too. So that's where the county sits for Sacramento.
Awesome. Thanks for jumping in on that one, Raleigh. Sarah is asking a question about someone who I saw was on the call with us to address the next question, which is, can we shed some light on the community impact program for those customers who may not have the finances for a project? So for those that aren't aware, SMUD is very engaged with our community, and we're focused on doing everything we can to bring our entire community along with us on this zero carbon journey. And so there are special programs that are out there to help those in disadvantaged communities, under-resourced communities, low-income communities that may not be able to participate in this decarbonization revolution. And that's what this program is addressing. And I reached out to somebody, Chadrick, are you still on the call? And is that something you can touch on? Or perhaps Ryan, are you involved in that at all? I'm personally not involved in that directly, so I can't speak to it.
Yeah, I can speak to it real quick. And just to introduce myself, Chad McInnes, the supervisor for the commercial programs here at SMUD, and support the Complete Energy Solutions program here that directly installs electrification measures at our small SMB customers throughout Sacramento County, and a part of that community impact plan project and program there. So in alignment with our sustainable communities kind of goals, who also lead SHINE grant efforts. So there are multiple ways to engage SMUD for getting grant dollars towards your energy efficiency type projects. But in addition to a SHINE award, if you're a small SMB customer that's engaged with your local PBID, for which SMUD is targeting for eligibility for various companies that are in our disadvantaged communities throughout Sacramento. I believe we've already completed 4 of those PBID outreach programs. We've highlighted over 45 customers that have taken on projects, and to date we've completed 13 projects and funded over $1 million in electrification so far in 2024. So we're making a big impact. We're putting our money where our mouth is and doing the work, and truly not leaving any customer behind in our efforts. And I'm proud of the programs here at SMUD. Ryan and John Barnes in the custom and IDS side, but as well as Barbara Matobi, who leads our Complete Energy Solutions program, and the effort and impact that they're making in the community in this space. So definitely engage our sustainable communities, and I'll put the Find My Advisor link here in the chat for the group's reference to get that engagement so that they can connect you with the appropriate folks at SMUD for these questions. But we'll also put the Sustainable Communities link in the chat here for the group's reference, because, yeah, we want to engage our community. We want to make sure that your needs are met. And these are the folks and the programs here at SMUD that are aimed to support those efforts.
Awesome. Thanks, Chad. Didn't mean to put you on the spot, but appreciate you fielding that one for us.
Absolutely.
Looks like we've got another question coming in about what about redundancy backup systems or lead lag systems? Are replacement parts available for the decarbonized systems? Are any of these systems modular or scalable, and how reliable are they? So a couple of different components in there. Anyone willing to take a crack at that? Jacob, you got your hand raised. Thank you.
Yeah, I can take this one. So how reliable are these systems? I know that Glumac has done multiple emergency operations centers going into it with all electric systems for new builds. So I would say customers are very comfortable with using these as reliable systems. And they do that through providing redundancy and backup equipment. You can think of it a lot of like a chilled water system. So just like you would have redundant chillers and backup chillers and lead lag systems in place, you can use that approach. So you'd have heating hot water pumps, N+1 pumps. You'd have N+1 chillers, or heat pumps in this case for your heating systems, and you can do it that way. A great way to do that is with modular heat pump units, where you can have, up to like 6 modules of heat pump units. Each module has 2 compressors and 2 refrigeration circuits. So if you lose one module, you still have your remaining 4 modules, and you can size those to provide the redundancy and the resiliency that you need for your project. And obviously, we don't want to make a customer have way more equipment and pay for that upfront equipment. So you want to strategize to do that the best way you can to give them the resiliency they need without overdoing the equipment.
Awesome. Thank you, Jacob. Anyone want to add anything to Jacob's response on that one? There's a couple of subcomponents to that and probably a million examples. I know Ryan always has a million neat examples that he comes across in his line of work, but don't want to put anybody on the spot. Andrea,
Yeah.
did you want to chime in as well?
Yeah, I think just the last piece on the modular is actually applicable to the case study we were sharing. Again, upfront costs can always be a big limiter on these electrification projects. What we're actually planning to do at the Bradshaw site is likely 2 different iterations of heat pump installs, and kind of phase those new buildings or those existing buildings coming online with the new electrification technology. So all the underground infrastructure would be in place if we did the centralized approach, but the air-to-water heat pump might not get built out all at once. So I've been enjoying the modular capabilities and being able to work with the ownership to make the first cost a little bit more achievable.
Good add on that, Andrea. Thank you very much. And between being over by a few minutes and no more questions chiming in, I'm going to very slowly say major thank you to our instructors. Behind the scenes, this group was amazing to work with, everyone. I can't be more appreciative. We're blessed to have this team come together to be able to provide all this information for us. Big thank you to Jacob, Andrea, Ryan, and Raleigh, who had to jump off. Thank you to our crowd for sticking with us a few minutes late and asking all the great questions. Really appreciate you. As always, reach out to us at SMUD, your account manager, your strategic account advisor, or Ryan or I anytime you'd like. Obviously, Andrea and Jacob are here to support from a consultant engineering role. And Raleigh's over at the county doing his best work as our solo mechanical engineer on staff. So reach out to any of us anytime if there's any follow-up questions, or please direct your questions directly to me. My email address that you can reach me at is etcmail@smud.org. I'll put that in the chat one last time. And finally, I plugged a couple more classes that could tie into your decision to decarbonize. Take a look at those. Maybe it makes sense for you to attend those as well. Always free and happy to have you. With that, have a great day, everyone. Thank you so much. Take care.
Thank you.
Yeah, thanks so much.
Thanks,
Bye.
everyone.